All right, today we're going to dive into a really powerful tool in programming, the do-while loop. Now, this isn't just another way to repeat code. Oh no, this is your secret weapon for those times when you know you need to loop, but you have absolutely no idea when you're supposed to stop.
I mean, just think about that for a second. It's a genuinely tricky problem, right? How are you supposed to write a set of instructions for a task when the number of steps is a complete mystery? This is a really common challenge in programming, and it's the exact problem we're going to solve today.
So that brings us right to the heart of it, how to deal with an unknown number of repetitions. Look, sometimes it's easy. You know you need to do something exactly 5 times or 100 times. But a lot of the time, you just don't. And for situations like that, you need a special kind of tool. Now, I'm sure most of you are familiar with the good old for next loop. It's fantastic, right? Perfect for counting from one number to another. But it has one major limitation, and it's baked right into its design. You have to tell it exactly where to start, where to end, and how to count. It needs all that info before it can even take the first step.
But what about scenarios like these? Imagine you're asking a user to type in a list of names and you only want to stop when they finally type the word end. Are they going to enter one name, 50? You just don't know. Or think about a shopping cart in a game that you keep adding items to until it hits a weight limit. Or a video game that just keeps feeding you new levels as long as you're winning. A for loop, well, it's just not going to work for these.
And that is where our hero of the day makes its entrance. Let's meet the do-while loop, a tool that was literally designed for this kind of flexibility.
The huge difference is right here in the definition. A do-while loop isn't about counting. It's all about a condition. The loop will keep on repeating a block of code as long as a certain condition stays true. The endpoint might be a mystery, but the rule for when to stop is perfectly clear.
And you know the best part is just how simple it is. You just write do while, and then right after it in parentheses, you put your condition. That's the question the computer asks itself. Then you put the code you want to repeat, and at the very end, you just write loop. That single word tells the computer, okay, go back to the top and check that condition again. It's a really clean, straightforward structure.
So, okay, we know what it is, but how does it actually, think? Let's break down the step-by-step logic happening inside this loop.
Now, this gives you a basic idea of the repeating statement. But to really get what's going on, let's visualize it with a proper flowchart.
Okay, so here's the most important part. The check happens first. The computer gets to that do-while line and immediately asks, is this condition true? If the answer is yes, it runs all the code inside that block. As soon as it hits the loop at the bottom, it zips all the way back to the top and asks that same question again. This cycle just goes on and on and on until just one time, it asks the question and the answer is false. The moment that happens, it completely skips all the code inside and just jumps to whatever comes next, right after the loop.
All right, I think the best way to really cement the difference in your mind is to see these two loops tackle the very same problem side by side. So let's set up a little showdown.
So here's our challenge. We're going to make a simple program where a user enters a number, let's say 20, and our program has to list out all the even numbers up to 20. It's a pretty simple task, and both of our loops are definitely up for it.
Okay, let's look at the code. Over on the left, the for loop is super compact. It basically says, hey, start a counter at 2, go up to whatever number the user gave us, and go up by 2s. It handles all of that logic in one neat line. Now look to the right. The do-while loop kind of separates things out. First, it creates the counter outside the loop. Then the loop itself only checks the condition. Here's the critical part. You are responsible for manually increasing that counter inside the loop. See that line I equals I plus 2? If you forget to put that in, you've just made an infinite loop because I will always be 2 and the condition will always be true. So this loop gives you a bit more flexibility, but also a bit more responsibility.
And really, this is the big takeaway. The result they produce is exactly the same, but the logic underneath, the way the computer is actually thinking about the problem, is fundamentally different. One is all about a predetermined count, while the other is all about a continuous condition check.
So, all of this naturally leads to the big question. How do you know which loop to use for your project?
Here's a super simple rule of thumb. If your problem sounds like, do this 20 times or count from 10 to 100, that is a job for the for next loop. It's all about the count. But if your problem sounds more like, keep doing this until the user quits, or keep the game running as long as the player has lives left, well, that is a classic case for the do-while loop. It's all about the condition.
And honestly, knowing which of these two powerful tools to pull out of your programming toolbox is a massive step in becoming a more effective and a much smarter programmer. You've got two different tools, each designed perfectly for a different kind of problem.
So, I'll leave you with a little something to think about. What's a process in your daily life, maybe a game you play or some task you do at work, that really runs on the logic of a do-while loop? I promise, once you start looking for it, you'll see that the possibilities are literally everywhere.